Hi everyone, my name is Yeshwanth Rayankula. I am here to do my final presentation on sentiment analysis and quality metrics in Amazon product reviews. I am working this project under the guidance of Dr. Chavaji Wang. Next slide. This is the basic outline of my project, which covers the introduction, the data description, data pre-processing, imbalance data set, exploratory data analysis, techniques and models used, topic modeling, aspect-based sentiment analysis, the challenges which I have encountered, conclusion and future scope. Coming to the introduction, my objective was to perform sentiment analysis to classify reviews as positive, negative, and neutral. I've also intended to perform topic modeling and aspect-based sentiment analysis to focus on specific features such as delivery, price, quality, and customer service. The source of my data is from Amazon, and it contains customer reviews for various products. My data size is around 301 MB, which has around 567,000 rows and 10 columns. I have acquired this dataset from Kaggle, and this is the basic description of each of my columns. The most important columns in this dataset are score and text. I have done basic pre-processings like handling null values, removing duplicates, and converting time data type to date type format. I have all my data set is basically imbalanced with which is skewed towards the score of 5, and I have handled that by balancing my data set, and these are the results. And later I perform EDA. These are few visualizations, and I have used word cloud for both positive and negative reviews. And I have used traditional machine learning models and NLP transformer model. And these are the results of the traditional machine learning models and the pre-trained Estelbert model. Moving forward, this is my topic modeling slide. These are the top words for topic 1. I have used LDA, latent Dirichlet allocation, and I have removed stop words, tokenized text, and vectorized data using count vectorizer to create a document term matrix DTM. And these are the top words for each of the topics. Like I have taken 5 topics, 1, 2, 3, 4, 5, and moving forward to aspect-based sentiment analysis. I analyzed customer reviews from clean text column to identify specific aspects and determine sentiments and that are associated with each aspects. I have also extracted aspects using Spacy by identifying noun phrases. I have used Vadar sentiment analyzer to calculate sentiment scores for each aspect, and I also aggregated sentiment scores to compute overall positive, negative, and negative and neutral sentiments for each of the aspects. These are some of the workloads for positive aspects, negative aspects, and some of the challenges for class imbalances. And I faced difficulty with running both model several times on my Jupyter notebook and even on Colab and Colab Pro. And computation was a major challenge during my project, so I have to purchase Colab Pro for computing, where I use T4 GPU. Coming to the conclusion, logistic regression model, SVM, and random forest. Compared to all the traditional models, logistic regression was a better performer, and compared to all the models, BERT model outperformed all the other models with an overall accuracy of around 90%. And my future scope would be using pre-trained BERT and fine-tuning the BERT model for better performance. Also, I also wanted to explore additional models such as Roberta and GPT, where I can use Roberta for better sentiment analysis and predictions, and GPT transformer for summary generations. Thank you. Now we'll go to the Python notebooks. So this is my first notebook which I have worked, which is the data pre-processing and data ingestion and data cleaning parts. So here I have done a few. So this was my initial data set classes, and I have balanced them to be all equal, and these are few visualizations. These are the most common words used. I have done sentiment labeling: positive with scores of 4 and 5, neutral with scores of 3, and negative with scores 1 and 2. So this is the sentiment distribution of the reviews: positive, negative, and neutral. Going towards modeling, I have done modeling, and we go to the data cleaning and EDA part. This is the EDA part. Yeah, these are the number of reviews over time. This is the average review score over time. These are the most common words. These are the workloads for positive reviews and negative reviews. And these are the top 50 words in all positive reviews, neutral reviews, and negative reviews. And this is the plot for helpfulness ratio versus the score. And I have saved this cleaned data set into a CSV file and performed data modeling on that file, which made my job more easy. And here I have done modeling using traditional models like logistic regression. This is the confusion matrix. These are the classification report and evaluation report for logistic regression, and these for SVM, and this is the confusion matrix. The performance of both logistic regression and SVM were pretty good. They were actually decent, but we can achieve a better performance and more accuracy using advanced models. For that thought, I used random forest, but to my surprise, the random forest achieved a lower accuracy compared to the rest of the models. And then I used an advanced transformer model, BERT, which gave the best performance among all the other models. So I took this and moved forward to develop my app. Before that, let's go to the topic modeling and aspect based analysis. So here I have used LDA, converted text data into document term matrix with limited features, and later I performed LDA with parallel processing. So here we can display the top words for each topics. So these are the 5 topics and the top words for each topics. The same is the visual for that. And I have used Vadar for sentiment analysis. Here you can get score for each of the aspects. So if this is an aspect, then the sentiment score will be this. For like these are for the top positive aspects. This is the sentiment score, and these are for top negative aspects, and these are the sentiment scores. The positive is the closest to 1 and negative is the closest to -1. Anything that's closest to 0 is neutral, and these are the workloads for positive aspects and negative aspects. And since I have taken Since I have taken BERT as my best performing model, I have moved forward towards my app using the BERT model. Before that, let's get into the project report. So this is my project report. These are all my links for GitHub repository, LinkedIn. This is my PPT. You can download my PPT right there, and you can check out my Streamlit sentiment analysis app right there, and you can even watch this video and this link. So let's go to the app. Before going to the app, let us go to the app code once. So this is the Streamlit app code. It basically consists of three parts. One, downloading the models and datasets, two, loading those, and three, creating tabs and applying the models. So the first part is like downloading the model. Since my model and dataset were of huge size, around 100 and 300 260 MB, I was not able to upload them to GitHub, and due to that I also tried using LFS, large file storage system, in GitHub, but it didn't work out well, so I had to use the Google Drive to store my models and datasets, and then I had to dynamically download those from there using the file IDs. To do that, you should actually make your file open to everyone and public so that you can download that quickly and easily. And after that, I have loaded my models and tokenizers and the dataset. And then coming to the Streamlit interface, the UI consists of three tabs. The first tab is the dataset summary, and the second tab is the insights, where you will have a few visualizations, and the third tab consists of the sentiment prediction. Here you will be having two options. Let's check that in the app directly. Where is the link in the report? Yep, this is my Streamlit app. So here you have basic dataset summary. This is my dataset, which has sentiment labels, and these are the basic dataset statistics. And coming to the insights, these are the score distributions with percentages, average review over time, number of reviews over time, top 10 products by review count. And going to the sentiment prediction, you can input an individual review or a data set, like a bunch of reviews with the required column. Like my column which I'll be performing analysis is on the clean text, so make sure your dataset has a clean text column. Even if it says review, just rename it into clean text since my model is built on clean text. So let's try this. The product tasted good. Let's say the food tasted good. Says positive. Let's say the food tasted great. Before was 92 and now it's 98. So terrible. It says negative. Say the food was not bad. It says neutral. So if we want to just upload a dataset, I have a sample ready. Let's try this out. So this is the uploaded dataset preview. You can just view, like this ends with the text column and it has a clean text column, and this is the generated sentiments prediction and the clean text column. And at the end I have added a couple of extra columns, predicted sentiment and confidence. So you can see the sentiments were predicted properly with a proper confidence score. So the app is out and running well. You can use this app if you have like a small amount of data or even a big amount of data. Since the model is BERT model, even a large amount of data can be used, sizing up to 200 MB per file. So thank you all for watching this video. Please like my video if you like it and if you find it useful. You have a great day. Thank you.